Here's a real-world workflow that you've probably built or you're going to build soon. Let's say you upload a file, send out a notification, and then do some background processing. In this video, we're going to build this workflow using .NET and three AWS services: S3 for file storage, SQS for background processing, and SES for sending out email notifications. We're going to build a .NET application that's going to allow us to upload our resume as a PDF document, and then we're going to do some analysis on this document to tell you how you stack up against other people with the same skills and possibly identify some gaps in your resume that you can improve. So this workflow is going to contain a couple of steps. The first and obvious one is uploading a file, and then we're going to send out an email as a notification, for example, to the administrator. The next step could be analyzing the file with AI, and then we can add more use cases on top. Now, the problem that you're going to quickly run into if you try to combine all of these steps into the same transaction, to put it like that, is you're going to make the entire workflow less reliable. So I'm going to take a step-by-step approach in building this workflow, and we're going to solve these problems as they appear. In order to build this functionality, I'm going to use free AWS services, who is also the sponsor of today's video. And these services are going to be S3, the simple storage service, SES, the simple email service, and SQS, the simple queue service. So let me show you how we can combine all of them inside of our .NET application. Integrating all three services from scratch would be very complicated, so I went ahead and wrote some plumbing code ahead of time, and I'm going to walk you through it, and this is going to allow us to interact with S3, SES, and SQS. So first, let me tell you which NuGet packages I have installed. So these are going to be the AWS SDKs, and I'm using the AWS SDK for S3, the AWS SDK for SES, and of course the AWS SDK for SQS. Now, on top of that, I'm also using the Extensions.NET Core setup library, which makes it easier to configure these services with dependency injection in ASP.NET Core. So I'm setting up my default AWS options, which I'm going to pull from my application settings, and I'm configuring the iAmazon S3 service, the iAmazon simple email service, and the iAmazon SQS service with dependency injection. Then I'm configuring some values from my application settings for S3, SES, and SQS, and then I'm adding a couple of services which are going to use my AWS abstractions to expose the functionality needed for storing files, for sending emails, and for publishing messages. Lastly, I'm configuring some minimal API endpoints where we are going to implement our actual workflow, and right now we don't have any endpoints inside. So this is what I'm going to build. Now let me also walk you through the specific services which are using the S3 dependencies. So here is the S3 file storage service. I have a couple of methods for uploading a file, downloading a file, and deleting a file. And the most important one is uploading a file, which uses the S3 SDK. It creates a put object request and sends this to our S3 bucket. Now, if you're new to S3, don't worry, I'm going to walk you through setting up your S3 bucket in just a moment, but I just wanted to highlight that I built this service ahead of time. Now, there's also the email sender, which uses SES to send an email. So what you have to do is initialize a send email request and then use the SES SDK to call the respective API method. And then the same goes for our message publisher, which is going to use the SQS service, publish a message to a specific queue. To send the message, we create a send message request and then use the respective SQS client to call the send message async API. So these are going to be our building blocks. Now let's see how we can put them together to start implementing our functionality. I'll head over to the document endpoint static class, where I'm going to configure the minimal API endpoints for this functionality, and I'm going to expose a post endpoint with the route of upload. Now notice that we have a base route of API documents as well. So here I'm just going to implement the functionality for uploading a file to S3, and we'll need to inject a couple of services to implement this. Now the first one is going to be the iForm file, which is actually going to represent the argument for our endpoint and is going to come from the request body. Then I need the iFile storage service, and this is going to leverage our S3 SDK for the implementation. And let's also inject an iLogger. I'm just going to specify the program file as the logger type, and then we can implement our endpoint. I'm going to start by dropping in some validation for the form file. So just some basic checks that the file isn't empty and that the content type is application PDF, because we only want to support uploading PDF documents. Then I'm going to initialize a try catch block, And inside of the try statement, we're going to create a unique name for our file. I'm going to keep the original file name, but also include a random GUID. Then I can call my file storage service to upload the file, and I can pass in the form file and the file name. Let's also write an information log that we have completed our file upload successfully, and then I can return some object that's going to contain my file name and a success message. In the catch block, I'm going to log the error represented by the exception, and let's for example return a 500 status code. So now I can go ahead and start my application and test out the file upload endpoint. Now in order to be able to upload the file, we're going to need a respective S3 bucket where we are actually going to store the document. Now the bucket name, which represents a logical folder in the S3 service that stores your objects, is going to come from the application settings. And the S3 settings class contains the bucket name and the region properties. So let's head over to the AWS console to create our S3 bucket, and then we can configure it inside of our application settings. From the AWS console, I'm going to look for S3, and the first option should be the S3 Simple Storage Service. And here you can go ahead and create your bucket. Now I already have a couple, and I'm going to be using this one inside of my application, but let me just walk you through the process of creating your first S3 bucket. Your first option is going to be choosing the AWS region where the bucket should be hosted. Then you can choose your bucket type between general purpose and directory, assign a unique name to your bucket, let's say my AWS bucket, and then you can configure a couple of additional options such as who is the owner of the objects written to this bucket. You can decide to block all public access to this bucket, which is the recommended approach, and it's going to keep the contents of your bucket safe. And how do you actually expose the files inside of your buckets? Well, you can use pre-signed URLs that you can obtain using the S3 SDK and then expose those to your client application. These pre-signed URLs are going to be short-lived, and they're going to allow secure access to objects inside of your S3 buckets. If you want to, you can enable bucket versioning, which is going to store multiple versions of the same objects if you upload another object with the same key. This is very useful if you want to keep a history of changes for your objects. And then you have a couple of more options related to encryption. Then you can configure your encryption settings, and once you're happy with everything, you can go ahead and create your bucket. Now I'm not going to be doing that. I already created my bucket, so I just need to take the bucket name and then set this value inside of my application settings. So going back to our .NET application, I'm going to create a configuration section in my app settings JSON file where I'll have an S3 settings section with the bucket name and the region values. So with this in place, let's go ahead and start the application and test out our S3 upload. I've set up a post request in Postman that's going to hit my API endpoint, and I've attached a PDF document representing my resume that I'm going to send in this post request. So if I hit send, I'm going to get this exception that I did not include an anti-forgery token in my API request containing a form file. And this is a new behavior of minimal APIs that you can fix by either including an anti-forgery token or explicitly disabling anti-forgery on your API endpoints, which is what I'm going to do. So if I now try to send this request again, we're going to hit the breakpoint inside of our application, and we can see if our functionality is working. So you can see that my validation passes because my content type is application PDF. We're going to generate a unique name for our file, which is going to represent the key inside of our S3 bucket. And then I can go ahead and create a stream for my file, initialize a put object request with the bucket name that I've configured in my application settings. And once I send this with S3, you can see that my request completes. So let's press continue. We should get a response back in Postman, but let's actually go to our S3 bucket to see if the upload was successful. So if I go ahead and refresh the objects inside of this bucket, you can see that my file is indeed created. The type is PDF as expected, and you can view some metadata about this file. Here's a unique URL for this object in S3. Now we can proceed to do further analysis with this resume. Now let's go back to our application and make this workflow more complicated. Our next example is going to upload a file to S3 plus send an email using SES. So I'm going to drop in the API endpoint, and then let's discuss the implementation details. It's going to be very similar to the previous example, so I'm not going to write everything from scratch. Now we are taking a dependency on the file storage service, so the same as before, and additionally the email sender and the email settings. So what's going on inside of the endpoint? Well, it's much of the same, except after uploading the file, we are sending an email. So for this, I'm using the simple email service where I can specify who I'm sending the email to, what is the subject and the body of this email, and then creating and sending a send email request. I'll show you what you need to do to configure this simple email service in just a moment. But for now, let's pause and let's examine what we have inside of our workflow. So we're already interacting with two distributed services, the file storage service and the email service. In our example, these are AWS services, but they don't have to be. They could be any other cloud provider or any other storage medium or email sending service. And the point I'm trying to get across is that if you keep adding functionality to this workflow and trying to fit it all into the same API request, you are going to make things very complicated and fragile. So I'm going to share one approach, how I think we can solve this in just a moment. But first, let's see how we can configure SES for sending emails. So from the AWS dashboard, I'm going to type in SES and head over to the Amazon Simple Email Service. What you'll need to do is configure an identity, which is going to allow you to send out emails. Now you can go ahead and create an identity either using a domain, which is the recommended approach, or an email address, which is the simpler approach and is going to allow you to test this out quickly. This is the approach I took, but setting up a domain isn't complicated. You just need to purchase a domain, add it here, and you're going to get a couple of DNS records that you'll need to configure for your domain in order to identify your domain with the simple email service. So I'm going to skip over much of these settings, as the default settings are enough for the majority of the use cases. And then this is the email that I'm going to use for sending my emails. Inside of my application, I'll have an email settings section with the sender and admin emails, and I'm going to bind this to my configuration object. In my example, these email addresses are the same for simplicity, but they don't have to be. You could have one specific address for sending out emails, and then a different address that's going to accept the actual notifications. In the endpoint, we're going to use our email settings object to fetch the admin email as the address where we are going to send the notification, and in the SES email sender, I'm going to use the sender email as the source or who is sending this email. So let's start the application and test out our second workflow. I'm going to update our existing request to now target the new endpoint, and let's go ahead and send a post request to the upload an email endpoint. And we're going to hit the breakpoint inside of our application. I'm going to step over the file upload, as we already covered this, and then let's examine the email sending. And you can see it's much of the same. We're creating a request object, configuring the respective values, and then using the SES client to send the email. So let's complete this request. First, let's head over to S3 and see if there's an object with this key. So if I go ahead and open my S3 bucket and type in the object key and filter it, you can see that this file indeed exists. So our upload completed successfully. Now I just need to head over to my email inbox to confirm that we've received the email. And if we open this email, you can see that we managed to send it successfully. So this is a notification saying that we've got a new document upload, and it contains some information that might be useful to our internal users. The email was sent using AmazonSES.com, so our SES integration is working as expected. Now let's see how we can improve this. And as an improvement, I'm going to add another endpoint, which I'm going to call upload and queue. And here I'm going to switch my dependencies from the email service to the iMessage publisher. And the idea with this is, instead of sending an email after we've completed the file upload, is we're going to publish some sort of event, let's say a document uploaded event. And this is going to give us much more flexibility in our workflow. We can then subscribe to this event from multiple consumers and implement the required functionality behind the scenes. One of the things that we might want to do is send a notification email, but then we can also introduce additional behavior, and in the future, it's also going to make it easier to introduce new functionality. When it comes to publishing the actual event, I'm going to use SQS as the service for transferring my message. There are a couple of other options, such as SNS, the simple notification service, which allows you to create a topic which can fan out the message to multiple subscribers. This can be useful if you want to have one-to-many messaging. With a queue, your messaging is typically one-to-one. Now, how you would do this in production is publish to an SNS topic, and then the topic is going to distribute the message to multiple SQS queues. The actual implementation is inside of the SQS message publisher class, and it's just going to create a send message request and send it to the respective URL. The queue URL is going to come from our application settings, so we'll first need to create a queue inside of AWS. So let's go ahead and do that. From the AWS portal, I'm going to look for SQS, the simple queue service, and you can see I already have a couple of queues. I'm going to be using one of them, but let me show you what you need to do to create a new queue. You can choose between a standard and a FIFO queue. A standard queue offers at least once delivery and best effort ordering, while a FIFO queue offers first in first out delivery and exactly once processing. Now this comes at the cost of throughput, so carefully examine what type of queue you need. Let's go back to the queues, and I'll go into the AWS messaging dev messages queue, which is the one that I want to use. And I want to copy the queue URL, which is the address where I'm going to be sending my messages. I'll set this value inside of my application settings, and now I can go ahead and start the application. And I'm going to update my post request to target the upload and queue endpoint. So let's go ahead and send this request, and we'll hit our breakpoint as expected. Go ahead and upload the file, which should succeed. Now let's see if we're going to publish our message. I'm going to create a message wrapper instance, which is going to contain some contextual information about this message. For example, we can add a correlation ID, which is going to allow us to track this message through our distributed system using something like OpenTelemetry to connect the traces. And we have our event data serialized as JSON, the event type, which can allow us to connect the message type with the respective handler. And then I'm going to serialize the entire message wrapper into JSON and send it using SQS. So you can see this completes, and we can go ahead and complete our request, and we should get the key for our file in S3 in the response, so we can use this to validate if this was successful. But if you go into your inbox right now, you won't see an email. That's because we didn't actually handle the message in SQS. So let's go ahead and confirm that our message is actually successfully published. If I go back to my queue that I used to publish this message, and then I click on send and receive messages, and I start polling for messages, you can see that one message shows up, and it contains our message wrapper object. If we examine the event type, you can see that this is the document uploaded event. So let's go ahead and close this. I'm going to stop polling, but our message is still in the queue, so we didn't actually delete it. In order to consume the messages from the queue, we need another component inside of our .NET application. SQS uses a polling mechanism for consuming messages from the queue. So you're going to need some sort of background service that's going to be continuously polling the SQS service for new messages. So here's an example of what that might look like. We have a background service that's going to start when my application starts, and I'm basically going to run a while loop. Inside of this while loop, I'm going to use my SQS client to look for any messages from a specific queue, and then if I find any messages, I can process them. The processing step is going to deserialize the message, and then based on the event type, we can send this for processing to the respective handler. Now, this does go into reinventing a messaging framework, and it's not something I intend to do. It's more of an example. And if you want good support for messaging with SQS, you can go ahead and look at something like Mass Transit or the AWS messaging NuGet package, which is built and developed by AWS. So in our example, we're going to handle the message, the document uploaded event, and then make sure that we delete this from the queue by specifying the queue URL and the received handle of this message. And finally, let me show you the handle document uploaded method. It's going to deserialize the actual event into a document uploaded event object, resolve the respective message handler, which is going to be an iEvent handler implementation, and then the actual event handler is going to use SES to send out an email, much like we did in the second example. Now, for all of this to work, we need to wire up a few additional services with dependency injection. So here's what's required. And now if I start the application and place a breakpoint here, and let's say here, right after we find a message, and also inside of my handler, I should be able to hit all three breakpoints because my message exists in the queue. So you can see that we immediately hit the breakpoint inside of the background service because we've got one message back from SQS. So let's press continue. We're going to then land into this method for handling the document uploaded event. And then this is going to allow us to invoke our event handler where we are going to send an email using SES. So you can see this completes and this finalizes my workflow. So I'm going to stop the application here and then let's do a quick recap of where we started. So we started with a simple upload to S3 using the S3 SDK, and then we wanted to extend this with sending a notification. Now you can imagine how we might want to also process this file with some large language model to figure out what data we can extract from it and do some analysis on that data. And there are a couple of other use cases that we can add on top of this, and doing all of this in one API request would simply be too much. So we decided to offload this work to the background using SQS and publishing a message. In the future, we might switch our message publisher implementation to instead use SNS and publish to a topic, which is going to fan out the message to multiple consumers. If you want to grab the complete source code for this video for free, be sure to check out the pinned comment right below. And if you are looking for a complete tutorial for working with the Amazon S3 service, be sure to check out this video next. Make sure to smash the like button on your way out. Take a look at my courses if you want to improve your software architecture skills. And until next time, stay awesome.